page 16 in your static electricity booklet. That's the part A of the electricity unit booklet. And we're going to talk today about the attraction of neutral objects. So a couple of days ago when we talked about the law of attraction and repulsion, we said that it stated that all like or same charges repel. So again, just I like to put the positive and the negative and negative around those like charges just to remind you what those are. And all unlike charges attract. So unlike could be negative and positive and negative, or positive and neutral, and negative and neutral. So that's what those -0 and +0, that is positive and neutral and negative and neutral. So in terms of positive and negative charges, this concept's quite simple. But neutral objects are attracted to both positive and negatively charged objects. And this is because they're unlike or unalike. So again, positive and neutral or negative and neutral will attract as well. And attract means to move together. So we need to look at what's happening to the electrons and protons inside the atoms of neutral objects in order for them to be attracted to the charged substances. And this is called polarization. So again, if we have neutral objects, so we show that it's neutral by having 3 positive and 3 negatives. So when we're drawing a neutral object, usually we have kind of 3 to 5 charges. 1 or 2, it's hard to show that charge separation. And if we have too many, then we lose track of counting and we make silly errors. So 3 to 5 charges when you're drawing a neutral object is perfect. So when we bring a positive rod near a neutral object, what happens is the negative charges, because remember positives can't move, so the negative charges are attracted to that positive rod. So they're going to move to the surface. And this is called polarization because we have one side that becomes kind of positive, and this side with all those negative charges near that positive rod becomes negative. Same thing if we bring a negative rod here. In this case, in this neutral object, negative and negative repel. So all the electrons or negative charges in that neutral object get as far away as possible from that negative rod. So it leaves this side positive and this side over here negative. And that kind of separation of charge in these neutral objects is called polarization. So here's a neutral atom or something, and we have 3 to 5 sets or charges. So you have positive, negative, positive, negative, positive, negative, positive, negative. So that's kind of that's 4. I gave you 4 there. So then I know it's a neutral atom because the number of protons is equal to the number of electrons. It's important that they're spread out equally throughout the object. If we're trying to show that separation of charge, it's important that we don't have that separation of charge before we even start to bring that charged object near. So if a charged object is brought near the neutral object, the objects will be attracted. So again, here's a negatively charged object and a neutral object. So this was my neutral object. When I bring that negatively charged rod, again, in that negatively charged rod, I'm only showing the excess charges. All the electrons move as far away as possible from that negative rod. And in reality, the protons wouldn't move at all. They're rigidly fixed in those atoms. All of the electrons on the neutrally charged object move as far away as possible from the electrons on that negatively charged object. The electrons in the neutral object moved away, allowing the protons in the neutral object to be attracted. Again, they're not really moving, but the idea is we separate those charges, and that's called polarization when we're talking about a neutral object. If a positively charged object and a neutral object come near each other, again, in this case, we've kind of exaggerated it by showing the positives away and the negative charges all lined up together. So in this case, all of the electrons move. All of the electrons on the neutrally charged object move closer to the protons on that positively charged object. The electrons in the neutral object moves closer, allowing the protons to be further away. Again, a couple of things. In reality, the positive charges wouldn't move, but we kind of highlight that separation of charge like this, that polarization. And again, just another note on these rods, I'm only showing the excess positive charges. There would still be some negative charges as well. Okay, so again, here's a little bit of a summary. If we bring a negatively charged rod near. Again, the negatives align further away. This should say positively charged. So if we bring a positively charged rod near, the negatives align closer to that positive rod. They're attracted. So polarization, in both of these cases, the neutral objects had an even distribution and an even number of protons and electrons, and it changed that distribution by moving the electrons around inside the object. That rearranging of electrons is called polarization and allows for neutrally charged substances to be attracted to both positive and negatively charged substances. So polarization means to rearrange electrons in a neutral object. So I've just got a couple of diagrams to show you here. In figure 1, we have charge separation. So typically in a conductor, the charges separate because they can, in a conductor, it'll readily give away those electrons. Charges polarize in an insulator. They just rearrange themselves in an insulator. So that's just a little bit of terminology there. What I've got for you today, unfortunately, I had 2 task 3s by accident in your booklet. So this one's called Drawing Charges. It's on pages 18 and 19 of your book. There's an example, and I want you to draw what it says. So basically, you might have to go back and look at these notes again because it is a little bit confusing, but you're going to draw a neutral object. Remember, it has to have equal number of positive and negative charges. 3 to 5 sets is the best, and they should be evenly spread out. When you draw a negatively charged rod coming near that neutral object, again, if the negative rod is coming near, you're going to see all the electrons repel as far away as they can. So you're going to be drawing that and reviewing your terms from the previous 2 pages. If you have any questions, please feel free to contact me on Teams, and I hope you're doing well.